This conference will now be recorded.
Yeah, welcome all. This is Nagesh Gowad from CNC Times. So I take this opportunity to say good afternoon to everyone and welcome for this webinar on coordinate. Yeah, on coordinate metrology. So here I would like to introduce the speaker. Our speaker is Mr. Kailash Pandare. He is basically a mechanical engineer, and he has worked with Machine Tools India as a application and salesperson, and he had very vast knowledge on the metrology, especially on the CMM. And last almost 4 years back, he had also started manufacturing of the, jaws. Basically, these jaws are required for the power chucks or CNC turning center chucks. So he's into manufacturing of these jaws now, and but he has a very, you can say, very deep knowledge on the metrology. So with this, I will not take much time. I will hand it over to Mr. Kailash Pandare, and at the end of the presentation, we can have the question answers. Yeah, over to you, Mr. Pandare.
Thank you, sir. Thank you, Nagesh, for introducing me to the audience. Good afternoon, everybody.
Afternoon.
Am I audible, sir?
Good afternoon.
Yeah.
Yes.
Yeah.
Yes, sir.
Okay. And
Yeah, please go ahead.
and my screen is visible to everyone.
Yes.
Yes.
Okay. So Nagesh has already introduced me to you, all of you. So I will not take much time on that, and will directly jump on the today's main topic about the coordinate metrology, right? So there is something like it says, if you can measure, then you can control it better. So it is all about the measurement. So I believe all the audience today who are the present for this webinar must be working on the shop floor, or they must be involved in product development, product manufacturing, or some kind of machining, fabrication work, or something they are making, right? So if we are producing it, and if we can measure it, then we can do it well. If we cannot measure it well, then we cannot produce it well, or rather we cannot control it well. So the whole process, whether it's a manufacturing or fabrication, machining, or even if you can say a call center or restaurant, if they cannot measure their performance, if they cannot measure their product performance, they cannot produce well in the future. So this is the whole idea of metrology, is the science of measurement, and we are taking only a small portion of that metrology part, is the dimensional metrology or coordinate metrology, right? So the coordinate metrology is basically something to do with the length measurement. Okay, so length measurement is the shortest distance between the two features, two geometrical features. It can be a 2 points, or can be a between two circles, or it can be a between two planes. Okay, or it can be a between two slant heights. Okay, so the very simple to measure the length, we have a, so everybody must have used this scale in school days, or a measuring tape, right? So this is the simplest length measuring instrument. So can we call this as a one dimensional, because it is just measuring a one dimension of the part? not more than that, right? So before going further, so we understand that dimensional metrology or coordinate metrology is something to do with the length measurement. Okay, but before going to next slides of my presentation, I like just to focus mainly on the word, accuracy, precision, and least count. So in MIDC or in any industrial area, if we are talking on shop floor, everybody says, I need more accurate. I want 0, 0. It's very common. Means if some customer comes to me and he says, I want JAWS, but it should run out should be 0, 0. So what is mean by 0, 0? Or what is that expectation at it has to be a 0, 0? So that is where this terms accuracy, precision, and least count comes in. Unfortunate part is many people they entangled this these terms to each other. Some people they mislead the least count with accuracy or mislead accuracy with the precision. So I'll not take much time on this. This is not a part of our the today's presentation, but since this is very well connected with our day-to-day life on a shop floor or on a vendor place or an customer end, so that's the reason I'm just taking this example. Okay, right. uh, many of us must have used vernier caliper, a simple digital vernier caliper, right? If you ask anyone on a shop floor or anyone who is using the vernier caliper, and if you ask what is the accuracy, what is the accuracy of this instrument, everybody will say it's the least count is 20 micron, so accuracy is also 20 micron, which is wrong, right? Accuracy is something different, least count is something different, and precision is something different. Accuracy is something, the ability of the process or the instrument or the machine to achieve the true value. Now who will set this true value? This true value can be set by the some accreditation lab or by some the customer. So there is a master value or true value which is set by somebody which is in authority, right? So I'll just bring your attention on this, the last figure. You can see this red dot. This red dot is a true value. Archer is supposed to hit all this arrow at this true value. The expectation is that every time this arrow should hit in this red area. That is, it should achieve the true value. For example, if we go to the McDonald's in Pune, or if we go to the McDonald's in Delhi, or if we go to the McDonald's in Chennai, the taste of the burger is same. That is the true value they are maintaining. So for the customer point of view, the expectation is that if I walk into any McDonald's, I should have to have a same burger test. So this is what is the McDonald's accuracy. They are fitting into the true value set in your mind. The same way, if our instrument is measuring something, it's our expectation is that it should measure the true value, right? So see, the true value should not be confused with our the drawing dimension. Suppose on drawing dimension, the distance between the two circle is as say 20 millimeter, and the tolerance is say plus minus 50 micron. If the instrument showing it as 20.080, that means 30 micron more, it doesn't mean that instrument is bad. Okay, we must have calibrated that instrument against some master value. On that master value, if that instrument is achieving that, that means that instrument is accurate. So accuracy is to achieve the ability of the process, instrument, or the machine to achieve the true value set by some authority. In case of instrument, it is masters, which are validated by the some national level accredited laboratories. Okay, so in this first case, you can see that our process, whether it's a measurement process or a manufacturing process or making burger process, is neither accurate and it is not precise. What is mean by precise? That means every time it is not performing. The performance is sometimes it's very good, Sometimes it's very bad. Okay. In second figure, if you can see, our process, our instrument or our machine is producing or giving a result which is repeating, which are very precise. That means we are getting the wrong value, but we are getting repeat value. We are not close to the true value. So this is precise and not accurate. And the third one, if you can see here, this process is accurate. It is trying to go to near to the true value, but it is not repeating every time the performance. Now the first figure here, the performance of the instrument or machine or making process is accurate as well as process is precise. That means every time we are able to repeat the performance. Every time we are able to repeat the performance, right? So this is the basic difference between accuracy and repeatability and precision. Okay, and you can say list count. So list count should not be mixed with the accuracy. Accuracy is different and list count is different. List count is something which is the least possible measurement done by that instrument or by the process. Okay, so I'm just going to the next slide. Okay, now these are some advanced sophisticated one dimension instrument. Okay, because we are able to measure only single dimension. This is a vernier caliper. You must have used, most of the people must have used it. This is a micrometer, and we have a height gauge. Some people call it as a 2D height gauge, mind it, but it is not a 2D height gauge. It's a, because it is giving only a single dimension, so it is not a 2D height gauge. It gives a single dimension, so we can call it as a one-dimensional measuring instrument. Now here you can see here, these are two. There are three different instruments, but the similarity is these instruments are measuring a single dimension. They are using only single dimension. So if we can have a diameter here, if we are measuring a diameter by vernier, we can do this diameter measurement using a caliper also, or a micrometer. Sorry, micrometer. So what is the difference between these two? Why should I choose micrometer over vernier? It's because of the accuracy of the instrument. So what process we are using to make this diameter will decide the selection of the instrument. Okay, if we have to have a very precision, then we should use a precise instrument. If we have a coarse manufacturing process, then we should go for this some not so accurate instrument, right? If we have to go for it, suppose at a time we need 2 dimensions, then we have to have something which can give us a result in 2 dimensions. In this example, you can see here, in this example, you can see here, we need x and y coordinate of this circle with respect to this circle, or also we need a dimension of resultant, that is r, between these 2 circles. So we can do it by 2D height gauge, but in 2D height gauge, then we have to shift it for 2 times. But now we have something called a profile projector. You must have seen this profile projector. And at a time, we can use easily the 2 dimensions between these 2 geometrical features. That is nothing but 2 circles, right? So similarly, you can use nowadays there is not nowadays, it's quite long back now. It's almost 15 years. We have now optical measuring instruments. We call it VMM, video measuring instruments, measuring machine, video measuring machines. They fitted with the camera, so you can have these dimensions appearing on the screen. So it's advanced version of optical profile projector. So we call it as a 2-dimensional, basically because it's giving us the 2 dimensions between the 2 features, right? Okay, next is, you must have seen this contour graph. I'm sorry, I just want to tell you one thing. I'm here as a neutral speaker, and I'm not promoting any of the brand. I'm just using their websites and their example to demonstrate. I'm not recommending anything. I'm not here to promote all their products. So we are here as a neutral neutral speaker on this product. Okay. So I'm sorry, I should have described this in the start of the presentation, but now just I've seen this name and it's come in my mind. Okay. Right. So there is another example of 2D measurement. It is, we call it as a contour tracer. So nowadays it is also a very popular measuring instrument, and you may find it across many standard rooms. And there are many companies, many different brands, they are making these contour tracers. So you can see here it is giving us radius, its angle, and the dimension between the two pitches. But it is again a 2D. It's not giving you the third dimension. Okay, it is just for a 2D purpose. For example, if anybody is from the crankshaft background, they must be knowing the the corner radius, the crowning crown radius. It's called on a pin diameter. So if you want to measure this, it's very easy to do with this contour tracer. Okay. Yeah, the contour tracer, then yeah, that's the reason it's giving us the only 2-dimension x and y, and it is not giving us the third dimension. That we call it as a 2D or 2-dimensional measuring instruments, right? Okay. Now nowadays, with the help of computer, now measuring microscopes are also there in the market. So if somebody is from electronics background who are into making of this circuit boards and all, so if you want to measure the circuits circuits dimensions, then we can have this measuring microscope. So microscopes are not only limited for this metallurgy. Nowadays they are using, the people are using it for the measurement purpose also, right? But again, it's a 2D. We cannot get the third dimension in this, right? So what are the challenges? What are the challenges we are facing with this traditional equipment? You can use a very high standard, very high accurate instrument to measure, say called say a diameter on the part, but at the same time you can use the vernier caliper also. So what is the difference? So see, if there is a repeated measurement, if 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 our process, if our manufacturing process says that this particular dimension has to be 100% inspected, so in that case we should have to have something which can do it repeatedly, right? So we can have a very high-end machines, right? With this with the standard equipment, with these traditional equipments, the manufacturing process is still measurement cycle is little bit slower. I still remember days when I used to visit escorts in Faridabad. That time we have installed, recently we installed CNC CMM, and this is something I am talking about in 2001. And CNC CMM was very new in India, and we have installed CNC CMM in escorts Faridabad, and whole cylinder block was measured in something like half an hour or something like 40 or 45 minutes, and everybody was amazed, because they used to have inspection by traditional layout method on this cast iron table, surface plate, using 2D height gauge, and it is used to take a lot of time, lot of time, and they were very happy to see this CMM doing their job very fast. The second most the biggest problem with this conventional methods is again a manual intervention. It's just imagine the if we are measuring something on a profile projector works mainly on shadow type. So if I have to pick up an age, and if I have some issue with my eyes, I may pick up a very wrong dimension, very wrong age, or I may use a different magnification. or somebody else will use a different magnification and pick up a different layer of the image, and it you start giving me the the discrepancy between the two measurements. So this is again a manual intervention will cause a lot of problem. The next problem is the reporting issue. If we are nowadays everywhere is the data. So if we want data to be fast from our manufacturing and measurement, then it should be recorded somewhere. With this instrument, with the conventional method, it is very difficult to record the reports and then share across the different stakeholders. If you want to share the reports to the design department, manufacturing people, or assembly people, then it will become very difficult. If we have a hard copies, then it is start getting somewhere uh, losing the report somewhere, something like that. So this is one of the issue with the reporting, right? And this is another problem with the sensors what we are using on this measuring instruments. Like as I said to you, uh, on profile projector, it is always it says that it's always to have a higher magnification to get a highest means the max possible accuracy. But many of profile projector users, they don't have the higher magnification lenses. Okay, so again, suppose the customer is using say 50x lens and I am using say 10x lens, there will be a difference between the result. There will be the difference between the the dimensions what we are getting. So this is again a wrong selection of or improper selection of probing. This is the biggest problem with this conventional methods, right? Although these are the challenges, but I am not saying these challenges are replacing vernier caliper or micrometer or profile projector. No, they are still in use, and wherever it's required, it is required the same thing. In my factory, on my shop floor, we don't have any CMM. We are all using only digital vernier caliper, micrometer, 2D height gauge only. Okay, right. Okay, now we are coming to the most advanced version of 3 dimensions measurement. Okay, as such, we have seen that we got 1 dimension output through vernier, then 2 dimensions output through either contour tracer or measuring profile microscope or profile projector. But then the question remains about the 3rd dimension, and then we have a CMM. Now we have all 3 dimensions, X, Y, and Z, uh, by using a CMM in all 3 directions. Okay. Before proceeding, I like to make very clear about the X, Y, Z dimensions, or we call it as a Cartesian coordinate system, or there could be a polar coordinate system where we have angle theta and angle, radius, and height. In Cartesian coordinate, we have x, y, z. Trust me, apart from x, y, z, there is nothing. If somebody says I have a 5-axis machine, I have a 6-axis CMM. Somebody says I have a 12-axis CMM manufacturing machine, or some people say something else. But everything boils down to x, y, z, or polar coordinate system, that is radius, angle, and height. Is that okay? Right. So we are going next to understand what is 3D coordinate measuring machine. We are on the topic of dimensional metrology or coordinate metrology, and we have seen so far it is something to do with the length measurement, and we are measuring length, either 1 dimension length or 2 dimension length, or now we have a challenges to, then we have a if we don't know what is the 3rd dimension, so we have a CMM which can give us the 3rd dimension. Apart from x, y, it is giving us the z dimension of the part also. Right. Now, what is the background of CMM? when it was started. To be honest with you, I'm not much aware when it was started, but I have seen one very old CMM in a company called Scooter India in Lucknow. This I seen in 2000, somewhere in 2. This machine was built by a company called Ferranti, and it was not that no, in advanced version. It was having hard probe here with the DRO. DRO means it was giving me XYZ coordinate, and then you have to take the probe, means that this hard probe, and you have to insert in, you have to put it into the hole, or note down the XY coordinate, put it in the next hole, note down the XY coordinate, use the Pythagoras theorem, then derive the results. So it was a long process, but still it was a very good, it was a at least some advantage to those people, because they should not have to have this manual inspection method. And then comes the era of in 2000. Then we have CMM starts coming from the outside. Some people started building CMM in India, and we have a DOS version. I don't know, many of you must have not used the DOS, this operating system, and it was yeah, still it was, it was a luxury for the quality control or metrology people to have a CMM, right? Yes, that was a story, means the history of the CMM in India. And then we got a CAD model, then CAD based inspection, and then nowadays it has gone. Now the measurement is not a challenge. You can do many things on a CMM, right? Okay. Now coming to the main topic, why we want to have a CMM? The most important is it's a fast measurement. Our measurement process is very fast. The cycle is very fast. Once you make a program, you can repeat it anytime. Just put the component, just show the references, and the machine will start measuring the part automatically. Okay. It is accurate. Yes. CMMs are accurate. Why it is accurate? Because no manual intervention. Okay. And since it is a program, the measurement is happening at the same place where it was programmed. Okay. So it is accurate. Okay. Sorry. In terms of inspection report, yeah, CMM gives a lot of advantage. I'll not tell one customer's name, but when we were there in commissioning the CMM, we were using that CMM for inspection of their car body. It was a car body measurement, BIW, body in white measurement, and then they have the third-party database software, which was monitored centrally by the design team, and we were uploading the data, uploading this inspection report onto that third-party software. So it was possible, because we don't have to write all those around 1,200 parameters on BIW on a paper and then print it or something like that. No. It was automatically going through the software to their central database, and their team was monitoring it. So in terms of reporting, yes, it is very advanced nowadays to use CMM. I'll give one example. See, if we have a connecting rod, if we have a connecting rod, and if you want to know the distance between the big end and the small end, so it's very easy, just measure one circle, measure another circle, run it in a CNC mode and take output, right? And you can give the dimension to, you can give this report to the production guys. He says, hey man, this dimension is supposed to be a 150 millimeter, but now it is coming 149.98. So you are 20 micron less, make a correction or whatever it is, right? But now just imagine, if you are manufacturing car panel or a side door or a bumper, and the part has come to you for inspection, then it's become very difficult. to give the report in terms of XY coordinate. You cannot tell, okay, Baba, this is coordinate has to be this much. You got this much delta variation. You make correction. No. So you have you need advanced reporting. Advanced reporting means I'll just show you the example when we come on that particular tab. How the graphical reporting done, so it becomes a live easy for the people who are using CMM. I like to bring your attention on this something, a last point called remote program. I remember a company in Bangalore. They were the software company, and they took up this challenge from Boeing or some other air industries. I'm not sure. I'm not remember. But they were doing the offline CMM program for this aerospace company sitting in somewhere in US. And these people were doing this offline program, CMM programming from here, inspection program. So they are making program from here. They are putting it in, in a proper inspection sheet, and then they are sending it to the these customers in the US. This area something need to be explored. We have a lot of now programmers available in India who can do the CMM programming. If they find this, then nothing like that. And now you know that in Europe and in those area, there is a very scarcity of this good programmers. All right, next. Okay, the working principle of CMM. Working principle of CMM is I'll just explain you in a brief. See, most of the CMM what you must have seen or you may see in market or in field, they are all called bridge type. Bridge type means what? This is, you see here, this is called bridge. So this is the typical CMM. If you take 100 CMM, out of 100 CMM, 90 CMM, you will have this bridge type CMM. If you don't see this type of CMM, people say you don't have CMM. But no, there are CMMs which are different shape than this. Okay. So this is called bridge CMM. And why it is called bridge? Because of this formation of bridge. Okay. Right. Okay. So you can see here, this is called y-axis. This is your x-axis. This is your z-axis. Again, I'm telling you, this is my convention. Maybe if somebody using some different make machine, they have this as a x-axis, this as a y-axis, this as z-axis, or some may have this as y-axis, this as x-axis, and this as z-axis. So everybody has different, nomenclature. Okay. Let me see if I can show you. Okay, and this is something I just took up from this hexagon site. Can you see this? Nagesh sir, can you see this image?
Yes.
Okay, right. So if you can see here, this is your this little bit of 3D dimensions. So this is your x-axis, or say y-axis. This is your x-axis, and this is your z-axis. All right. Now is that good? Okay. So this is your x-axis, y-axis, and z-axis, and this is your part get measured. Okay. Right. See this area. This is something called probe. Okay. So probe, the English word is probe. Probe means something the who inspect. You must have heard this word. The government have ordered the probe in this scam, that scam, this scam, that scam. So probe is something which goes and do the inspection. So this we have a probe here, right? Okay, and we have here on every axis we have encoders who reads the scale. These are scale. This is a Y encoder, this is Z encoder, and this is X encoder, and this is a probe. Okay, just a minute. Right, now you can see here this is a probe, and you can see here this is a ruby stylus. Okay, and this is the part, right? this is this particular probing system is called touch trigger probing system. I'll repeat. This particular probing system is called touch trigger probing system. So what do you mean by this touch trigger probing system? Means when you try to measure this circle, when you move this stylus against this wall, there is a pressure on this probe, this probe, and it got some sensor inside. This sensor sense that force and gives command to X encoder, Y encoder, and Z encoder to record that position. So once this is got recorded, controller will send that information to the software, which is of course with the computer, and X, Y, Z coordinate will be recorded. Now there are different algorithm. In that different algorithm, this data is get processed, and then you will have a circle dimension, point dimension, plane dimension, cylinder, cone, sphere, a line. So this all data, once it is got captured through this probe, it get transferred to the computer system. So this is called touch trigger. Touch trigger means what? It gets touch and it gets trigger. It gets touch and it gets trigger. It has got a strain gauge inside. Okay. Now this particular probe is made by Reneshaw. Again, I'm not recommending, I'm not branding anything, but I'm just using their image to demonstrate. So many companies, they have their own probing system. Some people have these continuous scanning probe. Some people have a laser scanner also. Let me see if I have laser scanner. Just a minute. Now you can see here, this is a laser scanner. Okay. So this is non-touch probe, means it is it's a non-contact type. It's called a basically non-contact type. So these applications are different. These applications are different. That applications are different. Okay. All right. So as I said to you, this is X, this is Y, and this is Z. This is touch trigger probing system, or you can have a non-contact laser scanner, or you can have a continuous contact probe, or you can have even optical video inspection system, camera based, right? Okay. And then the whole assembly here, all the guideways are moved on an air bearing. See, these air bearings and our normal bearing, they are different. Air bearings are worked, they are static, they are not dynamic, they are not moving anywhere, they are just sliding. They are floating and sliding on this. They are just floating and sliding on these guideways. Okay. Okay. And because of this, the inbuilt error on the machines come down. Okay. Right. And then we have a CAA, computer added accuracy. Now many of the this big brands who makes CMM, they have their own patented, or rather patented, I can say their own secret CAA, means computer added accuracy enhancement. So they don't just not keep lapping their machine. They use laser tracker and they build the error map of the machine, and then just they put it in the software. So the machine is 100% accurate. Means 100%, it cannot be a 0 again, but up to certain extent, if you see nowadays there is a competition between many people, like my machine is this much micron accuracy, then he says no, my machine is this much micron. So when I started my career, the accuracy of the CMM, and nowadays the accuracy of the CMM has drastically, there is a lot of change. Oh yeah, means sometimes sometimes I feel I won't believe on that, but yeah, it's true. There is a lot of change. Okay. Okay. Right. See, these are the three typical part of the CMM. This is a complete mechanical system where you have a machine loaded with air bearing, then probing systems, and then the joystick to move the machine here and there. And there are AC servo motors, there are encoders, there are scales, okay, and then their feedback goes in controller, and this controller gives the data to your software. And software, of course, again there is a international standard, and based on that international standard, there are a lot of software nowadays. There are third-party software, there are the software developed by the CMM company itself. So they process the data according to a certain algorithm, which is validated by the international standard called DMIS, Dimensional Measurement Interface Standard. Okay, right. Just a minute. Okay, just a minute. I'll just show you. We were talking about the graphical reporting. Nagesh sir, once again, please help me whether you are able to see this image.
Yes.
Okay, great. So this is something about the software. Sorry, the reporting I was saying. So this is a very typical component in general term. This is called free form. So there is nothing specific. There is nothing specific like a cylinder block or a con rod or a bearing. This is called free form. It's got a free form. Like you must be knowing, this is a computer mouse. Our computer mouse is a free form. So it's called a free form. It's called a free form. Now, if we have this kind of measurement to be done, what kind of action we will suggest to the manufacturing people? It's very difficult. It's very difficult. You cannot say, Baba, your x-axis has gone fire in this direction. Please correct it. You cannot do that. So what we have a color mapping on this part. You can see here. The red is means this is an area which is need to be immediate attention. The green area is something like it's okay. The blue area is in minus side. So as soon as the the stakeholder who is controlling this process, he sees this report, he knows what's happened. My die has gone wear out in this side. This is in the okay side. This has gone in negative side. So I have to take action on this. They will fill up some welding. They will do some machining here, and then they repair the die and they'll come back. Okay. So this is advanced reporting. This is the benefit of advanced reporting. And then you have our normal simple report, XY coordinate, angle between the two lines, the position, the runout, the concentricity, all GD&T parameters, okay, and then the distances and the coordinates, right? So this is the typical text format we have, right? Come back here. Okay, as I said to you, the probing system in India, it's still not popular to use scanner, but nowadays there are people who are using it. Yes, of course, there are people who are using laser scanners, but mostly used probing system is touch trigger or continuous scanning. Like if you have a Zeiss machine, you have a continuous scanning probe. If you have some other make, then you can have a touch trigger probing system, right? But yes, laser scanners are being used nowadays. Laser scanners are being used not for reverse engineering. Please mind it, for inspection also the laser scanners are being used in India also. Okay, right. We talked about the reporting. Yeah, this is one interesting part. You must have seen the bridge CMM everywhere, right? But nowadays, not nowadays, it's somewhere long back, there is a portable CMM. So what is mean by portable CMM? I'll just show you if I have something. Yeah. Sorry. Can you see this? Yeah, this is again a portable CMM. This is this works in a spherical coordinate system, but again it boils down to the XYZ. So you have portable CMM. Of course, there is a difference between bridge CMM and this CMM. This CMM is not that accurate as bridge CMM, and this is widely used in fabrication area where the parts are very huge. The measurements, the dimensions are not critical. I can't say critical. The dimensions are not that close tolerances, but they are critical. You got my point. Means I'll just give an example. There was a customer in Jamshedpur, and uh, he was making tractor parts. The tractor, there was attachment behind the tractor, and the tolerances on the dimensions was plus minus 1.5 millimeter. The tolerances were not so close. The tolerances were never close. And so sorry, it was not that close, but measurement was a critical issue. When I went there along with CMM, this portable type CMM, and we did the measurement using portable CMM, and it was done within 10 minutes. 10 minutes, the results were in hand, and they were all happy. And when they opened the part from the machine, and then again we measured, all dimensions were fired by 5 mm, and it took another 15 days for that customer, to set right those dimensions. So never says that if somebody is having a dimensions tolerances about say plus minus 1.5 mm, don't think that his or her life is easy. No. Sometimes it's very, not sometimes, most of the times those dimensions in microns can be set very easily, but those dimensions on such type of components, freeform type of components, is very difficult to set. So you have we can do that kind of inspection using this type of portable CMM. Okay, now we have a this type of CMM called gantry CMM. This again, let me see if I have that site's website now. That's a minute. That's a minute. That's it. Let's see on a hexagon. Now you can see here. I'll just right. I can see this machine. This is called a gantry CMM. Again, you have a y coordinate or x coordinate, and then you have a z coordinate. This is very useful for a high volume part. There is a, just a minute. I'll just show you this one CMM. Can you see this CMM? It's a huge CMM. X, Y, and Z. There is no surface plate here or a surface plate table there to mount the part. This kind of CMMs are also very being used in aerospace industries, and I've been to a customers in down south, and they were having this big machine where the satellite components were used to get inspected on this machine. So you just imagine 2-meter diameter dome shape you have to inspect. So you cannot have a normal CMM. You have to have this kind of gantry CM, right? Coming back to our presentation. Now horizontal arm CMM. This CMM you must have seen also. Many of you must have seen. This is called horizontal arm CMM. This horizontal arm CMMs is being used for car inspection. You can see here. This is called body in white car, and this is horizontal CMM. Sometimes it is a dual type. In both the direction, the car is being measured. Again, the extension of horizontal arm CMM is nothing but a dual arm CMM. You can inspect the car from this side also and that side also. So it is called dual arm. Right. Optical CMM. Yeah. So this is the extension of this is the extension of profile projector. Okay. On profile projector, it is you can do with only shadow. You can do only with the shadow measurement. But just imagine there is a electronic circuit board, printed circuit board, and you want to measure the distances between the connectors, the dot connectors. So with profile projector, it won't be possible. And nowadays there is a camera-based video inspection system or optical CMMs has come in market. Something like a measuring microscope. Okay, but measuring microscope, there is no moving stage, and in this there are bigger moving stage. So they are using optical CMM. All right. Okay. The next is indoor GPS. This is another kind of combination of different transmitter being used for CMM as a CMM. For example, I'm not sure if somebody has seen the program on Discovery of making a Ferrari. In that Ferrari, you must have seen the cameras are mounted. A lot of cameras are mounted, and the body in white comes in, and it starts clicking the pictures and then assembling it and comparing with the CAD model. So this is also a kind of CMM. So they are making a XY coordinate system in that camera, and then they are measuring it. So it is indoor GPS. Laser tracker you must have seen. Laser trackers is again for a volume measurement, a bigger diameters, bigger parts, railway tracks, roads. These are being used in. They are measured using a laser tracker. So this is what are the different types of CMM, and and there are a lot of evolution is happening nowadays. So let's see, we'll have more and more coming in market. Okay, all right. Yes, Nagesh sir.
Yeah. So
Nagesh sir,
I think yes. Yeah. So now the forum is open for the question answer. So participant, if you have any questions, please type in chat box so that Mr. Bandari will be easy and happy to answer all questions.
Good afternoon, sir.
good afternoon, sir.
Sir, I am new, sir. First time I am actually CNC programmer. I want to know about this 3D measurements. So really good, sir, for initial beginning. Thank you, sir.
Yeah. Thank you, sir.
Okay.
You are using a CNC machine?
Yes, sir. I'm actually
CNC turning, right?
Turning, milling, turn mill, up to 5 axis.
Yeah, but so you must be knowing the XYZ, right?
Yes, sir. Yes, sir. Sometimes I given to quality department. He will measuring it, sir. This one. Sometimes
Okay.
if we want to take this threading profiles, this all need to know practical wise. I will check it, sir. This one. Theoretically, okay, sir.
So for threading,
Which
Yeah,
thread we
for thread measure.
yes sir, which thread we don't know. Customer giving only a sample piece. So we will take from dimension from piece. Like this lot of jobs coming, sir.
Yes,
So these all
correct,
jobs
great.
actually we are given to outsource. We are not able to do in-house.
Uh-huh.
Not this much knowledge don't have
Okay.
our team.
See, sir, your good name, please.
Ramakrishnan, sir.
Rama.
Krishnan. Ramakrishnan.
Oh, okay. Okay, Mr. Ramakrishnan. See,
Yes, sir.
as far as the thread is concerned, the threads are most of the times are following into a very specific category, like metric thread or British thread or SMA threads, and they have their standards like minor diameter,
Yes, sir.
major diameter, and the
Diameter.
thread angle. Okay.
Yes, sir.
Yeah, major diameter, minor diameter, and the angle between them. So what you can have is the machine design book and the measurement done on the thread. So like suppose if you got some part from the customer and you don't know what thread it is, right? So what you have to have is the either a profile projector or a video inspection system where you can take a dimension of minor diameter, major diameter, the angle, and the pitch between the threads, and just match with the design data book, and you will be knowing, you will come to know whether it's M12 into 2 pitch thread, or it's a BSP thread, or it's a ASME thread. You will immediately come to know about it.
Sometimes it will be
But
tapered
yes, you
threads.
should have to have something.
Sometimes we got
Yeah,
it.
see,
Tapered thread means a lot of tapered threads, sir. API or buttress or this one lot of confusion, sir. That is a problem.
yeah, but that's what I'm saying. You have any instrument to measure those threads?
No, sir. We have
Are you using any
CMM.
instrument?
We don't know, sir. Actually, we are using
So
only
CMM will not.
sir, we are not able to do.
No.
Training there.
No. Sir, CMM you will not be able to capture all the dimensions. What kind of threads you are getting? Suppose if you are getting a pitch size of say 1.25 mm, so it is difficult for the the stylus going in between the two thread between the two thread itself. So it is difficult for you to measure the threads. Yeah, of course. If those threads are a bigger size, then you can use CMM, but for smaller threads, you cannot use CMM. If the pitch is say 1 mm, 1.25 mm, or 1.5 mm, no, CMM cannot be helpful, sir. In that case, you have to have a profile projector, or you can have video inspection system. Yeah.
Okay. Thank you, sir.
Mr. Rajendra has
Thank
one
you, Mr. Ram.
question. He wants you to elaborate on the air bearing.
Okay, Mr. Rajendra. Yeah, it's good. Somebody has asked me this question. Okay, so what is these air bearings are? Air bearings are basically, these are not like a dynamic air bearing which we are find in general application like automobile or some machine tool application like spindle bearing or any bearing on rotating type. No, these are different. These are a static bearing. What we have a circular bearing having inside. Sir, is it possible, Nagit sir, is it possible for me to drawing something here?
Yes, you can.
Just a minute.
Okay. On top you have that tools on top of this.
Yes,
Yeah,
yes.
you can.
Yeah, I got it.
Yeah.
Okay, right. Sir, this is the front view. Mr. Rajendra, this is the front view of your air bearing, okay? Right.
Yeah, I think Mr. Rajendra is actually now he is busy, so maybe we will ask him to talk to you directly. Mr. Rajendra, I think you
Okay.
can talk to Mr. Pandey directly. His numbers, I will share you his number. Okay. Okay. Any other question? Any other question?
Sir, there is a question.
Yeah.
We already know all these basics, sir. In YouTube only we available all these basics.
Okay, sir.
We want to know something different than this introductions class. So far we registered on this. But you are saying only basics.
Yes. You want to know about the programming?
Oh, yes, sir. I want to know about the
CMM programming.
programming. In Calypso,
Yeah,
we are using
that
this
will
CMM.
cover. See, this is a basic introduction. We will come up with that programming and other thing in next program.
Is this only for 450 rupees registration for only for basic class only, sir?
Yeah, it is. 499 rupees. Yes.
For only for 450 rupees for only this class only.
Yeah, others are also attending that. So if you have any queries, I think we can discuss one-to-one.
What about the programming class? Sir? We have to pay for more than for that.
No.
Sir, if you have any queries,
Programming.
we can talk to you on one-to-one.
No, sir. What I am asking, every day you are doing class from 3 to 4 p.m.
No. See, actually, this is the first time we have launched our CMM webinar. Okay.
Okay.
So now this is our first program. We really wanted to have feedback from the people, what they would like to know. They would like to get into the advanced or like that. So if you have some queries, just email us. We will capture that in our next and intimate you.
So what I am asking means we already know all these basics, sir. What you are saying is accuracy, precision, and types of CMM machine.
Okay.
We already know. We are expecting more than this.
Okay. So I think what I am requesting you is that please let me know what you require. We will accordingly schedule that.
By using CAD model doing programming, and also by using manual.
Yes.
Yeah,
Sir,
Mr. Pandare, I think you can talk now. Yeah.
Sir,
Yeah,
one
like
thing
that
is very
we
sure.
expected. Yeah.
Yeah. It is something. It's very important to understand the CMM programming. Means I know I can understand. Many of you must have come across with a lot of different software, and they have a different methodology to do the inspection, and your outcome of inspection is depend on how you use the software. Like you said, CAD to part inspection, or a simple prismatic component. Yeah, manual alignment or automatic alignment, or there are a lot of types of alignment. Like simple is plain line point alignment. Some people have RPS alignment. Some called best fit alignment. Where to use, how to use. Like
That's all I am asking. That's so much important on CMM machine. Is all everyone know YouTube, sir?
No, that's okay. But one thing is, sir, it's not so something like we can cover up in an hour. Like if you talk about the PLP, plain line point system alignment, it takes at least half an hour to discuss. Okay, and then if you talk about RPS, reference point system alignment, which is earlier it was been patented by VW. Now it has been got released. So many of the software they are using PLP as their own alignment. You will find it in PCD Maze, you will find in Cameo, you will find in Calispo, or you will find in Power Inspect or VSUP. You will find RPS. But earlier it was not the case, right? So where to use RPS, right? Reference point system, where to use it. So if we start talking about RPS, it will take another, at least an hour. So on webinar, I don't think all these alignments and like say GD&T. GD&T is one of the part of CMM. GD&T is altogether a different part, but it's one of the part of CMM. Like I'll just give a small example. Like if there is a plane, there is a plane. On that plane, say plane dimension is say 100 by 100 mm, and there is a small cylinder in center. Height is only 10 millimeters. Now,
Yeah.
in drawing, they ask you the perpendicularity of this cylinder with respect to plane. On CMM, what you did is you calculate the perpendicularity of plane with respect to cylinder. Now you got a different result. The interpretation of the GD&T parameters itself has got changed, right?
Yeah.
So this is not something it's not something that we can cover in an hour. Like I'll tell you one simple example.
Sir,
Concentricity.
what I'm
It's the
asking is,
most.
this course will be continuing further days. Only this course
Yes.
for only for this day only.
No, sir, we will continue this course based on the feedback. Like just you ask us. Well, now we have.
Okay.
I started thinking how I will, keep.
For introduction purpose, this is okay, sir.
Yes, sir.
Okay.
I do
Nothing
understand.
about
That's what
the
I'm saying
CMM,
is.
this is okay.
Yeah,
Yes,
please,
sir.
yeah, Mr. Reddy,
We will.
please give your feedback. Maybe on the email, we will definitely incorporate.
Okay, sir. Is there any webinar on tomorrow, sir, on programming?
Not immediately, sir. Not immediately. See, this is the first time. That's what Mr. Nagesh has told you. This is the first time we did it, and we are happy to understand from the customer. Like just like you said, Mr. Reddy, that you are looking for a programming. Like suppose if we start getting inquiry for the people who are working, who are looking for the programming side of you, then we will have a webinar on the programming.
Okay, sir. We want to know about the programming, sir, in Calypso. Calypso.
Okay.
This software.
Yes, sir. Yes. I know it's on the right machine. So you are basically you're only interested in Calypso or overall methodology of the software to be used.
Methodology, sir. I want to know about the overall methodology.
Means you are aware of the Calypso. That means you know how to do it in Calypso. Only you want to understand how to do it, right?
I already done a course on Calypso. Okay. So for that case, I have to. I only know about the Calypso, but I want to know about the total methodology of the software. How they are
Sure,
doing.
Will Nagesh sir? Yes, sir. Nagesh sir.
Yes.
We'll note down the Mr. Reddy's point.
Yes.
It's good suggestion.
Yes. Anybody else has got any suggestion? Please let us know, because as we mentioned that this is our first program on CMM, and Mr. Pandare is already expert, but just really we wanted to know how we want to capture different subjects. So if anybody has got any more suggestions, please do write us about that suggestions. If any, I think if you have any questions, we'll take it, or we will conclude here only.
Then discuss about the working condition of CMM. How much temperature is required? In which condition it will give the accurate reading?
Okay.
Yeah. Correct.
Pressure condition. What's the pressure required for CMM machine?
Okay.
The pressure.
Ambient temperature. You are asking about the conditions, right?
Yeah.
All these conditions will be included in this webinar only, sir.
Okay, sure, sir. Sure, sir.
And also the voltage. How much voltage it will require? 230 voltage with 3-phase current.
Mr. Reddy, I'll tell you one thing. When we were installing one big CMM in India, and there was a foreigner came from UK, do it, and he was surprised to see the voltage stabilizer and UPS. He was asking me, what is this? And I said, this is a stabilizer along with the UPS. He said, what do you mean by stabilizer? I told him, we have to have a stabilizer. We stabilize the voltage coming from our, government electricity. Then he said, what is this UPS? And I said, this is the UPS which, gives us uninterrupted power supply when there is a failure of electricity. He said, why it is get failure? He got a lot of curiosity about stabilizer and UPS. It's a good point that you have come up with this. Yeah, will include in next this thing, sir. Sure.
Okay.
Yeah. Yes, sir.
Yeah.
Nagesh, sir.
So yeah. So if we have, if we don't have any questions, I think we will conclude now. Thank you all participants. Thank you, Mr. Pandare.
Hello, sir.
Thank you, sir.
Yeah.
Sir, do we have to pay for our next webinar?
We will let you know.
Okay. Thank you.
What you are
Yeah, no,
expecting
sir,
from the next webinar?
No, sir.
The programming only.
So you are looking for programming on which platform? On DMS platform, Calisport platform,
Calispo,
or a general?
sir. General or Calispo, both only.
We need to discuss this, Nagesh, sir.
Okay. No issue. We will.
Yes.
We will discuss. Yeah. We will discuss and take it. Okay. So thank you all participants. Yeah.
Hello.
Mr. Dinesh. Yes.
I am looking for programming of a turbine blade.
Turbine
I
blade.
have a component. Yes, I have a component. I have a model.
Okay.
So I would like to learn on the machine itself.
Which machine you have, sir?
We have Core 3 CMM.
Core 3
Which type?
CMM.
Yes. And
Which
the software
you
will be, and the software is ArcoCAD.
ArcoCAD. Okay, it's again Italian software.
Yes.
So you haven't got a formal training on the ArcoCAD or what?
Yes, I would like to train on ArcoCAD. Only on a turbine blade component.
Turbine blade, yes. Turbine blade, there is a different methodology. You know, turbine blade has to be inspected across the different sections.
Yes.
Okay, there will be a twist bow, and there are the radiuses which is gone into it.
Yes.
I don't know whether ArcoCAD has got all these parameters which you are looking for.
Yes, it is having.
You are making turbine blades for aerospace, or you are making turbine blades for a steam application?
For steam, thermal steam.
Thermal steam.
Yes.
So you are from Hyderabad region?
Yes, we are from Hyderabad.
Okay. Yeah. So you must be doing it for BHEL, right?
Yes, exactly. Yes.
There are different softwares are available for inspection of turbine blades. So
Yes,
turbine blade is not simply only a turbine blade. You have to understand its geometry completely. You have a lean twist bow in turbine blade. Then you have to have understand its alignment across the section.
Yeah.
Okay.
Okay.
ArcoCAD, I'm not sure, sir, because I never use ArcoCAD. I have to see that how.
Okay.
But this option must be there. I don't think there is any issue in having this option on ArcoCAD.
We are having it. We are already using it for internal inspections and external inspections.
But then what is the problem? You are not getting the what output you are looking for?
No, I just want to learn the CM, the QC inspection itself.
No. Can you please repeat again?
No, I would like to learn completely on the itself. How we are doing
Oh, you
the
want
inspection
offline?
on
You
profile.
want offline training for that, right? Then
Yes, exactly.
this will not be possible online.
Online, okay.
Okay, anyway, we'll note down. We'll see that what the best we can do it in.
Is it possible to come to your site?
I really need to discuss with Mr. Nagesh. We not expected. Means this kind of questions we are not expected on today.
Okay.
But yes, we'll see and we'll come back to you.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay. So if anybody is having any question, we will still take it, or we will conclude now. And I request everyone to write their feedback individually to me. I think I will just type my email ID. So whatever suggestions you have, please let us know. I just type my email ID nagesh@cnctime.com. So please forward me all your suggestions for the next program. Thank you so much. Thank you, Mr. Pandey. Thank you, all participants.
Thank you, sir.
So
Thank you.
yeah. So now we will conclude. Thank you. Bye.
Bye bye. Thank you, sir.
Bye, sir.